Hello all, welcome to my YouTube channel 4 Circuit. Recently I got shortlisted for this EVA Smart Transportation Design Challenge organized by Element 14 community, where they are going to select the 5 challengers and they are going to provide a kit from Analog Devices, Molex, National Instruments and Arduino. So the problem statement is to create a prototype of smart electric vehicle or smart system for next generation of vehicles. It could be prototype EV vehicle or auto charging EV parking space, battery management or battery insert system, speed monitor prototype, or anything related to electric vehicle. So as part of this kit, the challengers are going to receive the 2 sets of Eval ADM 3068 EBZ evaluation board from Analog Devices and LabVIEW trial from National Instruments and 3 sets of MX150 receptacle cable from Molex and then 2 sets of Arduino Uno QSPC. Let's see more about the kits they are going to provide. The first one is the Eval ADM 3068 EEBZ. This is an full duplex RS485 transceiver from Analog Devices named ADM 3068, which has the capability of doing 50 Mbps of full duplex transmission and reception. Next is the Arduino Uno QSPC. This is a combination of an MPU and an MCU. MPU from Qualcomm QRB2210 and an MCU from STM32U585 containing a 2 GB of RAM. These are the 2 major components of the kit. So for the challenge, I have proposed the EVA Guardian as a project. Means it's an intelligent EV battery insert system, safety and emergency redundancy system. So as a part of this challenge, I am going to make a series of videos related to the build phases of this project. So as a first video, this is a complete project overview along with the in-depth technical architecture of the system. Let's see more about the project overview. Electric vehicles have transformed personal transportation, but challenges such as range anxiety, battery degradation, connector failure and emergency preparedness continue to impact user confidence and safety. EVA Guardian is a smart EV monitoring and safety platform designed to provide comprehensive battery insight, predictive safety diagnostics, emergency assistance and backup power redundancy. The project combines battery analytics, connector health monitoring, vibration based incident detection and emergency SOS functionality. Using the Arduino Uno QSPC, Analog Devices isolated communication hardware, Molex automotive connector and LabVIEW visualization tool. So when it comes to the problem statement, modern EVs provide battery percentage information but often do not offer sufficient visibility into actual battery health, remaining usable range, battery stress condition, connector degradation, vehicle vibration anomalies and emergency communication readiness. Here is the high level diagram of an EVA Guardian, where the system is split into 2 nodes, battery management and profiling node and safety and emergency node. In a battery management and profiling node, the system will consist of an RS485 transceiver to have a communication with other nodes and then Arduino Uno QSPC to act as a brain of this node, along with the main battery management system consisting of an voltage measurement, current measurement and temperature measurement of the battery. And next, this is the safety node, where this also consists of an Arduino Uno SBC along with the RS485 transceiver and inertial measurement unit to detect some abnormalities of the vehicle when it met with an accident or some fallover of the vehicle. It will have an redundant batteries also, where when this battery goes bad in the accident or if this battery goes dead, this IMU and emergency system still able to work with this redundant battery. Let's see in detail about this project. The project will focus on 4 major areas. Battery insert system. It will monitor and analyze the battery voltage, current consumption, power usage, temperature and charging behavior. Based on these insights, it can able to assess the state of charge, estimated remaining range, battery health index, efficiency metrics and remaining runtime estimation. One more feature which it's going to add on is the connector health monitoring. Automatic connector degradation can lead to increased resistance, excessive heating, power loss, intermittent failures. So using Molex automotive connectors, the project will monitor the connector temperature, connection continuity and voltage drop across the connectors to detect the connector degradation trends. When it comes to the EV safety monitoring node, the system will continuously monitor the sudden impacts, excessive vibration, vehicle rollover condition, and abnormal motion patterns. In these states, the system can send a SOS message to the friends or any relatives. Let's see in detail the component level architecture of the system. The whole system is going to power by the 18650 lithium ion, 2 cells of 18650 lithium ion battery, which is protected by HX2SA2 BMS. Along with that, I am going to use an 2 ampere lithium ion USB based battery charger. So inside the system, it is consisted of an current measurement system, voltage measurement, temperature measurement, and then communication part. I am going to use the ACS723 as a current measurement module and LF412 op amp to do the voltage measurement, and voltage divider circuit connected with this NTC to monitor the battery temperature. This is incorporated with an safety relay as a safety switch, where the system will trigger when there is an when there is detection of high temperature on the battery to disconnect the battery from the overall system, and during some emergency SOS, the system can trigger this relay to cut off a battery power. And I am going to use this RS485 transceiver to have a communication with the other nodes. In this system experiment, the other node will be incident detection system. The Arduino Uno continuously monitor the current, voltage and temperature. Based on that, it will infer state of charge, state of health, battery condition, battery temperature, and it will keep on broadcasting those information to the incident detection node. One more interesting point is implemented here is the eval board will support full duplex transceiver loopback connection, where it needs to be where it requires a jumper of LK3, LK4, LK5 and LK6 to be connected to do an full duplex loopback transfer communication. So to utilize that feature, I am going to use a 5V 4 channel relay module. In the upcoming videos, I will explain this combination of circuit where it is going to help. Next is the incident detection system. So this incident detection system is fed with this one more two set of 18650 lithium ion battery with the BMS. This is an redundant battery system. This incident detection system consists of an auto power switching method relay, where it is going to get a power from the battery management system always to run this system. Due to some abnormal condition where this battery goes off, where this battery goes dead, this incident detection system will only power through this redundant battery to sustain and to act as an emergency SOS system. So the system is consisted of an IMU GY 91 MPU 6500 and an RS485 transceiver to have a communication with other nodes. Here also I have implemented the same logic to incorporate full duplex loopback for the ADM3068 transceiver. So in this system, it will always monitor the abnormalities in the vehicle, whether there is an accident detection or fallover or a rollover condition. In this condition, it will send a signal to this battery management system to trigger the relay, where it is going to disconnect the battery from the overall system. So to avoid some more rigorous accidents or fire catching of the system. So here is a complete list of BOM which are going to require to build this system. You can access all the project related information related to the unit code or the architecture development stages or the complete system information you can access using this GitHub repo 4 circuit EVA Guardian. I am going to share it in the description also. Thank you. Stay tuned for the upcoming videos to know more about the build phases of the EVA Guardian.